For our last video in this section, we're going to talk about finding second derivatives. If 2x cubed minus 3y squared equals 8, I want to find d squared y dx squared, which is our dy dx version of the second derivative. Take a moment, copy down that problem. Well, in order to find the second derivative, you first have to find the first derivative. So we're going to go and do our derivative normally of this thing. I want to go find the derivative of 2x cubed minus 3y squared, the derivative of 8. You go take a moment, make your formula for dy dx. We've done much harder examples than this. I think you can go make your dy dx equals formula. Six x squared minus 6y dy dx equals 0. 6x squared equals 6y dy dx. Divide both sides by 6y, so dy dx equals 6x squared over 6y. This is looking like x squared over y. Did you get that for your first derivative? I now need to find the second derivative, which means find the derivative of dy dx equals x squared over y. I'm going to go find the derivative of both sides of this thing. I want to find the derivative of dy dx, and I want to go find the derivative of x squared over y. The second derivative is just the derivative of the first derivative. So now, what's the derivative of dy dx? Well, this is my symbol for the first derivative. What's the derivative of that? The symbol for the second derivative. D squared y dx squared equals. On the right, you need to go use quotient rule. Let's see if we can do this. Low y, d high is 2x, minus high x squared, d low is dy dx. Draw the line, square below, it's all over y squared. I'm going to get 2xy minus x squared dy dx over y squared. However, my second derivative should only have x's and y's in there, not also a dy dx. I need to do a little bit of work to get rid of my dy dx. Any ideas how I can get rid of dy dx? Well, I know what dy dx is. I have a formula for dy dx. Oh look, what do you know? Right over there. I'm going to take that formula and I'm going to plug it in for dy dx. I'm going to get d squared y dx squared equals 2xy minus x squared times x squared over y, all over y squared. This gives me a second derivative of 2xy minus x to the fourth over y, all over y squared. I'm not okay, though, with fractions inside fractions. See if you can take a moment, multiply the top and bottom by something to get rid of your fractions inside fractions. I'm going to go multiply the top and bottom by y. And I'm going to get d squared y dx squared equals 2xy squared minus x to the fourth all over y cubed. That is my second derivative. We're going to use these second derivatives of implicit functions in the next unit when we start talking about curve sketching, and I want to figure out some details about the shape of the graph without actually going to the graphing calculator or Desmos to graph it.